All right, for this quick lesson, what you should have in front of you is the yellow sheet I gave you of the Maclaurin series that I said you need to memorize. So I want to talk about these for a quick minute here. Basically, this sheet is like the parent function for a lot of functions that we may want to evaluate or manipulate using series instead of using their regular form. So these first two, I don't really need you to memorize these two, but what's really important that you notice is that with these, this is in a over 1 minus r form, right? So 1 over 1 minus x is really a over 1 minus r form. So to make the series, you don't have to memorize the series. You just have to memorize that the first term is 1 and that r is whatever you're subtracting, 1 times x times x times x. So all I really care about with these first two is that you notice that if you have a fraction in a over 1 minus r form, it's geometric, and you can find the series from there. Then e to the x. E to the x is a very simple series. With e to the x, what you have is 1 plus x plus 1 over 2 factorial x squared plus x cubed over 3 factorial x to the fourth over 4 factorial. For e to the x, all of your derivatives are 1. So again, if you have f of x equals e to the x, then f prime is going to be e to the x all the way down. And when you evaluate all those to get a Maclaurin at x equals 0, when you evaluate that, what's going to happen is you have e to the 0, which is 1, all the way down. So when you go to write this series, you have 1 over 0 factorial x to the 0, plus 1 over 1 factorial x to the first, plus 1 over 2 factorial x squared, plus 1 over 3 factorial x cubed. And that's how this series for e to the x was born. All right, so then sine x. Well, if you look back in your notes a couple pages, so if you turn a couple pages back in your notes, we did a Maclaurin series for sine x over here. So if you look back at your notes on the series for sine x, you're going to remember that sine x went 1, 0, negative 1, 0, 1, 0, negative 1, 0 for all of your derivatives, which is why the series for sine x is x minus x cubed over 3 factorial. I'm missing x squared because that derivative was 0, plus x to the fifth over 5 factorial, and so on and so forth, so that the general term is alternating and has odd exponents and factorials that match the exponents. Cosine, therefore, is basically the exact opposite of sine. Instead of having all odds, cosine has all evens, but it too alternates, because if I have y equals cosine x, then y prime is going to be negative sine x, y double prime is going to be negative cosine x, y triple prime is going to be positive sine x, and then the fourth derivative, I'm getting back to cosine x. And if we evaluate all of those at x equals 0, I have 1, 0, negative 1, 0, 1. So I have 1 over 0 factorial x to the 0, plus 0 over 1 factorial x to the first, plus negative 1 over 2 factorial x squared, plus 0 over 3 factorial x cubed, plus 1 over 4 factorial x to the fourth. I have all the evens, and it goes positive, negative, positive. So your cosine function is all the evens, and it alternates. Okay, so let's say you want to memorize this. Ready for stupid human tricks with Mrs. Vibber? It's really stupid memorizing tricks with Mrs. Vibber. Sine is odd, cosine is even. Cosine starts with C. C looks a lot like an E, E for even. I know it's really dumb, but C looks like E, E for even. The cosine is all the even exponents. Sine is all the odds. All right, ln x. ln x is x minus x squared over 2, but no factorial, plus x cubed over 3 minus x to the fourth over 4. As far as memorizing this goes, You don't really need to memorize it, but this is one where I would really just want you to create it yourself. Because if I have y equals ln 1 plus x, my first derivative is going to be the derivative of the end over the end. And then all my derivatives after that are really going to be power rules, because this is 1 plus x to the negative 1. So negative 1 plus x to the negative 2. Y triple prime is going to be positive 2, 1 plus x to the negative 3. And then when we plug in x equals 0, the original function is 0. The derivative is 1. The second derivative is negative 1. The third derivative is 2. So when you go to write your series for this, you have 0 over 0 factorial x to the 0, plus 1 over 1 factorial x to the first, plus negative 1 over 2 factorial x squared, plus 2 over 3 factorial x cubed. And what happens with these as you go forward is 2 over 3 factorial. Basically, the 2 cancels with the 2 underneath, 3 times 2 times 1. And you have 1/3, and that continues to happen, which is why you see this pattern. I would really say in the scheme of things, you don't need to memorize this. It's really not a big deal, but I wanted you to at least know where it comes from and how to get it. If you can memorize it, great. If you can't, whatever. And then inverse tan, we actually did this a couple lessons back by saying, well, inverse tan has a derivative that's in a over 1 minus r form. So if you write out the series using a over 1 minus r for f prime, then take the antiderivative of that, you get this. Honestly, though, if it were me, I would just memorize the series for inverse tan because it's not that bad. The series for inverse tan is very similar to the series for inverse sine. All right, ready for stupid human tricks? The series for inverse sine is x cubed over 3 factorial x to the 5th over 5 factorial. Inverse sine has a factorial. This is really dumb because sine has an I, and an I flipped upside down looks like an exclamation point. Inverse tan does not have an I in it, therefore it does not have an exclamation point. I know it's dumb, but I swear to God, you're going to remember that and be like, oh my God, it totally worked. So, long story short, I've been yammering on about this for a while here, for 7 minutes. Long story short, to memorize these, remember Mrs. Vibber's stupid human tricks. All right, what do you have to be able to do with these? Well, you basically need to take those and then be able to manipulate it like this. So I'm going to quickly number these. I encourage you to do the same. That's supposed to be a dot. 8, 9, 10, 11. Okay, so let's say I want to write a series for each of the following functions. So 1 over 1 plus x cubed. So for number 1, 1 over 1 plus x cubed is really just a over 1 minus r, right? So a is 1. R is negative x cubed. So I multiply by negative x cubed. I multiply by negative x cubed. I multiply by negative x cubed. And so on and so forth. And it says, write a Maclaurin series using a manipulation. State the first 4 non-zero terms in the general term. Well, my general term for geometric is going to be a times r to the n minus 1. Number 2, I want you to go back and do that one on your own after you're done watching the video using the method I just showed you. Number 3, okay, so now we're going to modify series. So if I want to modify sine, the first thing I would do for 3 is say, well, sine x, S doesn't look like an E, so it's not even, it's odds. And sine has an I, which is an exclamation point. So I need all the odds. So x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. And then negative 1 times, this is going to be x to the 2n plus 1 over 2n plus 1 factorial. And when n equals 0, I need it to be positive, so that's going to be an n. So there's the sine series. Well, I didn't want that. I want negative sine of what now? 2x over 3. Piece of cake. All you do is negate everything and replace x with 2x over 3. So now it's going to be negative 2x over 3 plus 2x over 3 cubed over 3 factorial minus 2x over 3 to the 5th over 5 factorial. What did I do here? I forgot my factorial. There we go. Plus 2x over 3 to the 7th over 7 factorial. Now I need my general term. Well, my general term is just going to be to negate this and replace x with 2x over 3. That's it. Seriously, that is all you do. You don't even need to simplify it. There you go. Done. All right, let's see. Number 4, negative x plus sine x. Well, I'm going to do number 4 with you. What happens when you add? Well, when you add negative x plus sine x, whatever you do on the left, you also do on the right. So on the left, I added a negative x. So on the right, I'm going to add a negative x. Mrs. Favorite, do you add the negative x to every term? No, adding isn't distributive. Adding just happens once. So if I had a negative x to the left, I add a negative x to the right, which really means this term just disappears. So I just get negative x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. I asked you to do the first 4 non-zero terms, so then it just means the next term would be plus x to the 9th over 9 factorial. Mrs. Favorite, what about the general term? Do you have to add negative x to the general term? No, the general term doesn't change. The general term is the same. Whenever you add or subtract to a series, it does not affect the general term at all because adding or subtracting is not commutative. There you go. All right, so let's do maybe 1 or 2 more. Let's do 5 you can do on your own, so put 5 down here and leave a space. 6 I'll do with you. X e to the negative x squared. Okay, so first I want to do e to the x, then I need x e to the negative x squared. Okay, so e to the x. E to the x is that simple one. 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the n over n factorial. There's the series for e to the x. Okay, now I need x e to the negative x squared. Well, I have to take all the x's and replace them with negative x squared. Okay, I can do that. So this is going to be 1 plus negative x squared plus negative x squared squared plus negative x squared cubed plus negative x to the, I lost the thing, plus negative x, what was it, negative x squared to the n over n factorial. So far all I've done is I've dealt with the negative x squared. So I replaced x with negative x squared. So all the x's got replaced with negative x squared. But Mrs. Faber, what about the x? Well, what about the x? I have to multiply the left-hand side by x, which means I need to multiply the right-hand side by x. So don't write this, don't write this, don't write this. So what I really have to do is I have to multiply all this stuff by x, which means I distribute because multiplication distributes to addition. So what does that really mean? It just means I'm going to go in here with my little marker and say 1 really becomes x. Whoops, I didn't want that marker. 1 really becomes x. So if you want, write this like this. I want you to write this. Write that like that, which really is x plus, well, negative x squared times x is going to be negative x to the 3rd. So you could make that minus x to the third if you want. Then this is negative x squared squared, which is really x to the fourth, times x, which is x to the fifth. Negative x squared cubed is negative x to the sixth, times x is x to the seventh. And so then my general term here is going to be x times negative x squared to the n over n factorial. And if you're really feeling smart, you can say, well, aren't these all odds? They are all odds. So you could also write your general term as x to the 2n plus 1. But the odd on top doesn't match the thing on the bottom. So like when x to the seventh is here, that would be an n equals 3. So then down here, n equals 3. This would just really be over n factorial. When n equals 3, that's over n factorial. And then I have a negative 1. And so x to the seventh is when n equals 3. N would be odd, making it negative. Yeah, I could rewrite this as negative 1 to the n, x to the 2n plus 1 over n factorial. Or you could make things easier on yourself and leave it kind of unsimplified as that. All right, so I am done yammering on about all this stuff. I would like you, before you come to class tomorrow, to finish the rest of these. Do some manipulation tricks and try to finish the rest of these, and we will go over them in class. All right, I need a joke. I didn't look up any jokes today. Oh no. Um, um, I'm stumped. I can't think of a good joke right now. What do you get when you cross a parrot and a shark? I thought of one. What do you get when you cross a parrot and a shark? I don't know what it's called, but it'll sure talk your ear off. All right, it's kind of a pirate joke. So I hope you have a good evening, morning, night, whatever it is, and I will see you guys soon. Bye.